There is nothing in nature that is completely disordered, and there is nothing in nature that is completely ordered. Instead, there is an entire spectrum ranging from almost perfect order to almost perfect disorder.
On a city street where pedestrians are walking in both directions down a narrow pathway, you get a spontaneous formation of lanes. You get some people walking in narrow lanes one direction, others in another direction. They intersperse in a very orderly kind of fashion. Over time, however, you kind of see drifting and shifting of those lanes, and there's a chaotic flow to the system. So you have order that is kind of locked into a system that is also disordered and chaotic.
We have shown that by locking a system, a plankton system, into a container, the work of a German collaborator looking for 10 years, what happens when you have this system exposed to a constant environment. And what appeared is that the system keeps changing over time. And we could show mathematically that this is chaos. So chaos happens in nature. And that means unpredictability on the long term, but only of the details. And we can still say, for instance, what are the conditions for a lake to become green with phytoplankton. Even though we cannot predict which species will be abundant, because on that more detailed level, the dynamics are chaotic. But that doesn't prevent us from predicting the larger patterns that are actually quite regular.
In physics, one would think that in the course of time, the final state of a system will be disorder. That's kind of what the second law of thermodynamics suggests. However, biological and social systems are characterized by an inflow of energy and information. And that creates new kind of structures, new order.
There are certainly zones of extreme predictability in human behavior, and then there are zones of extreme unpredictability. And in times, the line between the two is really quite ambiguous. Thus, for example, it's very clear that in certain industrial societies that we follow 9-to-5 lives, 7-day weeks, and so on. But there's no reason why you couldn't have a society that was based on very different rhythms and very different patterns. If you looked at a hunter-gatherer society, it would look quite different from the United States. And the United States probably looks a little bit different from Spain.
And in our research on social networks, we find lots of different orderly processes, like the tendency for people to choose to be friends with each person who is like them. So liberals tend to be friends with liberals, and people who are skinny tend to be friends with people who are skinny. We also find in social networks an orderly process where people with lots of friends choose to be friends with other people who have lots of friends. And this is one of the things that gives our networks a unique shape, this orderly process that we go through when we're making individual decisions.
Well, the order in a language community is the amount of sharing that takes place. And the sharing is then directly impacting communicative success. So the more conventions are shared, and the more the meanings are shared, the more the participants in the dialogue will have success, even if they haven't spoken before. Now, on the other hand, we have this disorder because everybody has their own idiolect and their own history and so on.
I have a very particular belief to say there's very little disorder in complex systems. You know, for example, my behavior to you who don't know my habits may appear to be completely disordered. You can't say where I'm going to go tomorrow. You can't say what I'm going to do 5 minutes from now. None of that is disordered from my perspective. I know exactly where I'm going to be tomorrow, and I know exactly what I'm going to do for 5 minutes from now. So often the disorder is not a true disorder in these complex systems, but it is a lack of information about the mechanisms and the motivations that drive the particular nodes or particular components in the system.
The disorder on the large scale is what we try to simplify with complexity theory. So what we want to understand, what we want to do is to rationalize this disorder and make it an order in a sense. So what we want to do is to simplify the system, to find understanding usually corresponds to simplification, and this is what we are trying to do in complex systems.
Knowing about something means in this context being able not only to say something about it, but also to predict. And we can predict things when they are orderly. It's very, very hard to predict things that are disorderly. So the idea in the studies of convex large complex systems is that we look for patterns of order, if only because those are the ones that we can describe and hopefully predict in their behavior.
When you perform a scientific description of an event in a complex system, you have two kinds of description. One which is, let's say, at least at the short time scale, a deterministic description, and another which is a statistical description. Statistical laws are often as robust as a deterministic law. They only need, let's say, the size or the time necessary to converge is enough long. But when you have the condition for a convergence of the statistical laws are as solid, as important, and as crucial as the deterministic laws.